So let's continue exploring the pole in the barn paradox, but now let's imagine that we are moving with, we are in a frame that moves with the pole. So x and t now measures, x and t is the frame in which the pole is at rest. So the pole is, here's the pole, that's the left end, and this is the right end. And so as time t passes, the left end just moves upwards in the space-time diagram, and so does the right end. So this is a pole left end, pole right end. And now we have the barn that's moving towards the pole. So it's moving leftward. And so we can draw this on the space-time diagram of the pole observer, the pole frame. So the time axis, right? We need to draw the space-time path of the left end of the barn, and it's going to go, at some point it will reach the left end of the pole, but it can't go at 45 degrees. It has to go a little bit less, so we have to go, I think that's tilting enough, just above the 45 degree line. And so this is the barn left end. The barn right end, from the perspective of the pole observer, the barn is contracted because it's the barn that's moving. So the barn will not allow the pole to fit in at a moment of time, at some moment of time t. So this is the moment of time t when the left end of the barn is approaching the left end of the pole, and so we can't go through here because then, from the pole perspective, the pole fits in the barn. So we need to go through, say, here and make a line that's parallel to that one, because that's the space-time path of the right end of the barn. So this is barn right. So we can see that from the pole perspective, it's the barn that's moving, and so these are slices of simultaneity. This is the left end and the right end of the barn at different moments of time, and suddenly we see the barn appear, the left end of the barn appear, but there's never a time when the entire length of the pole, which is this, if that doesn't change, fits into this region. It would have to fit in like this. It certainly isn't fitting here, it's not fitting here, it's not fitting here, and so on. The pole doesn't fit in the barn from that perspective, but from the other perspective, we know that it does. So the other perspective measures spatial slices that are tilted. Right, so this is tilted by some angle with respect to the vertical. That's the t-bar. So these would be slices t-bar, and we want slices x-bar tilted like that. So that's an x-bar slice. This is an x-bar. And so from this perspective, from the perspective of the barn, right, we see that here is the left end of the barn meeting the right end of the barn. And then here is the left end of the barn meeting the left end of the pole. Of course, the door is open. There's no contact there, as we've seen from the other perspective. So at this moment, we need to see where the right end is. And so we're going to move along that direction to see the left end of the barn and the right end of the barn from the barn perspective. And then when the left end of the barn meets the left end of the pole, we have that the right end of the barn also meets the right end of the pole. And so from that perspective, the pole does momentarily, at some moment of time, t bar, fit in, as we already know. And then later on, the left end of the barn moves further left, and if we want to know where the right end of the barn is, we're going to move this way, and it'll be there. So we see the same sets of simultaneity, right? This is simultaneous with this is simultaneous with this, and this is simultaneous with that from the barn perspective. From the pole perspective, this is simultaneous with that, right? This is simultaneous with that. Right, we're looking at this is simultaneous with that. This is simultaneous with that, and so the sets of simultaneity are different, but the physics is the same. Another version of this paradox can be explored by assuming that the right door of the barn either is closed or doesn't exist, and so that the pole crashes into that. But there we sort of have to add some additional physics to see that the physics is actually the same.